Hi, I'd like to say a few more things about doing math in Python. So I want to tell you a little story first. When I was teaching Python to third graders, so you heard stories that kids nowadays start learning programming really young. Well, that is true. So anyway, one of the first things that these third graders try to do was that they try to figure out how big of a number can they type in Python. So what they do is they just keep holding down a number key like the 3 for a really long time, or they just kind of type random digits, and they try to construct a really big number and see what happens in Python. So that's all great. So it's a fun story, but that does raise the question then, what is the biggest number that Python can support? And how can we find out? Well, so instead of, just like kids, they have to keep typing digits in their Python editor. Well, what we can do is that we can use a little bit of math to try to derive a really big number, right? So one of the easiest way to do that is actually to raise a number to some power. That will give us a very big number very easily. So the number I'm going to try, or I'm going to demo here, is the number Google, which is spelled Googol, and I think that's the name that Google has is a play on that word. It's a really big number. So that number is 10 to the 100th power. So if we want to do that, we can type this out, 10 raised to the 100th power. And we can print this number out and see what it is. So let me run that. And that is, a 1 followed by 100 zeros. And as you can kind of tell, Python doesn't break a sweat. It just like, oh, okay, well, I'll just print out this really humongous number here. And with that, you can actually make this number bigger, right? Okay, can we raise 10 to the 1000th power? And you can do that, and you can run it, and it will again be a really even 10 times as big. Or actually, no, way more than that. It's going to have 1,000 zeros rather than 100 zeros, but the number itself is a lot bigger. But anyway, that's a really big number, and again, Python doesn't seem to break a sweat doing that. So it will probably break at some point, or it will take a long time to compute at some point. But my conclusion when I was asked this question was that there doesn't seem to be a hard limit on how big a number that Python can support. I think it's limited by maybe the amount of memory or the amount of computing power that your computer has, but there is just no hard limit. And going back to the third graders who I just told you about a moment ago, they never figure out the biggest number that Python can support either. They just ran out of patience and stopped trying to create a really big number that will break Python. So the second thing I'd like to talk about is division, specifically this expression of 100 double slashes 5, and we call this the floor division. So you probably had a lot of questions in your mind at that time, so maybe like, why is it called floor division? Why is it not just division? Or why does it have 2 slashes? And what if I just put a single slash? What does that do? So let's look at their differences. And here I'm going to have these 2 statements here. I'm going to print out 100 divided by 5 using both double slashes and a single slash. Now I did say not to do computation in the print statement, but I'm doing this here because I want it to be quick, and for demo purposes, it's okay. All right, so I've already typed it out here, so let's run it and see what happens. Well, as you would kind of expect, both of these give us 20. However, these two 20s are not exactly the same, right? Because the first one is an integer, and it does not have any decimal points. The second one is what's called a floating point number. So it's not an integer, and a floating point number is simply a number with a decimal point. So this is 20.20 or 20.0 or 20.0. So they are different, and the differences would be more obvious if we change the number here to say 3. And let's run it. And you can see the real difference here, that we know 100 divided by 3 is not going to give us an integer result, well, at least in the normal math that we do. Now, however, the floor division does give us an integer result, 33, whereas with a single slash, it gives us the result that we normally would expect from 100 divided by 3. So what it is, well, the first one, 2 double slashes, we've already seen, and it uses an integer result. Now, more formally, the result that it gives us is the largest integer that is less than the normal floating point result. Okay? Whereas a single slash, or what Python calls the true division, or simply just division, it would yield the normal result that we human beings would normally expect with the decimal point. So it's a floating point result. So that's the difference between using double slashes, the floor division, and a single slash, the true division. So true division is something that we are very familiar with. The floor division, on the other hand, might be new to some of us. So to make sure that you truly understand what floor division does, here is a little exercise that I would suggest you to do. Is let's try printing out 5 double slashes 2 and 5 double slashes negative 2. And well, obviously before you run this code, you should figure out by hand what they should give you, and then run the code and see if it matches your expectations. So please pause the video and give this a try. Alright, so hopefully you have done it, and the results may or may not be surprising. So let's do this together. I've already typed out the code and I'm going to run it. So the first one is the 5 double slashes 2 give us a 2. So that's probably expected because, well, 5 divided by 2, we get 2.5, and the largest integer that's smaller than 2.5 would be 2, right? Now the second one, 5 floor division, negative 2, it gives us a negative 3. It may or may not be what you expected, but here's the logic, right? We know that 5 divided by 2, negative 2, in a true division is going to give us minus 2.5. And because it's minus or negative 2.5, the largest integer that is smaller than negative 2.5 would be negative 3. And that's where it gets the result from. So yeah, negative floor division is a little trickier, but I hope it makes sense. So you might want to ask, why don't we do true divisions all the time? I mean, after all, that's what we learn in math, and so why do we bother with floor division? Well, there are a couple of reasons. For one, anything that involves just integers, such as floor division, is, from a computer hardware's point of view, takes a lot less hardware to do, and it's a lot simpler. And for something that is simpler, it's usually a lot faster. So if you want to actually do, say, the true division in using floating point numbers, it takes actually a lot longer than floor division. So if you want speed, and if integer division is okay, that's what you want to do. And the second thing is, depending on the particular application you're using the divisions in, integer results might actually be preferred, might actually even be necessary, or if neither of those, it might be good enough, because it might not be obvious at this point, but a lot of things in computer is discrete. To give you an example, the screen that we're looking at right now is composed of a lot of pixels, right? You've heard of terms like 1080p, which means your screen or your TV, the resolution is 1920 pixels horizontally, and there are for each line on the screen, and there are 1080 lines on the screen. So each of the pixels on the screen is addressed by a pair of numbers, and they are integers. So in computer graphics, we do a lot of scaling. To do scaling, we do a lot of divisions. So to decide any particular pixel should have some particular colors, we do divisions, and because the pixels themselves are addressed by pair of integers, the division we do in those cases are very often just the integer of 4 divisions. So that's why 4 divisions are can be very useful, and that's why we study them.